So hi guys, welcome back to another video. So in this video we're going to solve this problem, special product list. It's a medium level problem. So let's see the problem statement. Given a list of integers nums, return a new list such that each element at index I of the new list is the product of all the numbers in the original list except the one at I. Okay, and do this without using division. So we don't have to use division here. So let's see the sample. Sample is 1, 2, 3, 4, 5. So output is 120, 60, 40, 30, and 24. Okay. Okay, so let's see the sample here. We are given 1, 2, 3, 4, and 5. So what we have to do for every index, we have to find the value, and the value will be the multiplication of all the numbers except that index value. Let's see how. For this, it will be 2 into 3 into 4 into 5. For this, it will be 1 into, we will leave 2 into 3, then to 4 into 5. For this, it will be 1 into 2, we will leave 3 into 4 into 5. For this, 1 into 2 into 3 into 5. And for this, 1 into 2 into 3 into 4. So we'll get these values. So this will be an answer. So how to find these values? Okay, so for first is the very naive approach, we can call it as a brute force. So what we're going to do, we'll apply two loops, and for every index we'll find the value using the second loop. How? Let's see. So for first loop we'll do like this. For int I equals to 0, I is less than n, I plus plus, and what you know, we will store, we will take a variable, suppose t equals to 1, and what are we going to do, another loop for int j equals to 0, j is less than n, j plus plus, and we will put a condition. If I equals to j, then we will continue, else t is equals to t into nums of j, which is our array nums of j, and after this loop we will put this value t into our answer. So this is a very naive approach, which is a brute force, and its time complexity will be O of n square. Simply what we are doing is, for every index we are finding the value using this loop for every index. Okay, so this is a brute force approach, and this is very trivial and time complexity of n square. But how we can optimize it? How we can optimize it so that the time complexity reduces to O of n? So how we can do? We can pre-compute some values. Like, let's see how. This is given, suppose 1, 2, 3, 4, 5. Okay. So let's take this index. Let's take this element 3. So for 3, what we were multiplying? We were multiplying 1 and 2 from this side, 4 and 5 from this side. Like we were doing for this 1 into 2, and for this we're doing 4 into 5. That is, we were multiplying all the right elements and all the left elements. Okay. So what about we pre-compute these values? What if we pre-compute these values so that we can find this value, we can take this value in without any loop, without applying any loop, in O of one time? How we can do? We can store these values. How? Let's see. So let's take an array prefix and suffix. So in prefix, what we will do, we will store the multiplications from the left side. How? Let's see. For this, it will be, let's take here an array 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So for prefix, it will be, for first, it will be 1. And what for 2, it will be 1 into 2. And for this 3, what we will do, we'll multiply it with a previous value. So for 3, it into 2 equals to 3 to the 6. And for 4, what we're going to do, we will multiply 4 with 6, so it will be 24. And for 5, we will multiply it with previous, so which is 24, so it will be 120. So we find the prefix multiplication, like we say prefix addition, like it's a prefix multiplication. And similarly, we will do for suffix, like we will first find this, store this, we'll store this 5, and we will multiply 4 with 5, so it will be 20. So we will multiply 20 with 3, so it will be 60. We'll multiply 2 and 60, so it will be 120. We'll multiply 120 and 1, so it will be 120. So we found the prefix and suffix. We found the prefix and suffix array. Now how we can use this? So let's see. So again, let's take here the array. And okay, so now let's take for the first index. For the first index, the answer will be 2 into 3 into 4 into 5, which is the multiplication of all the rightmost elements. Okay, so for all multiplication of all the rightmost element, we have already pre-computed this suffix, which is the multiplication coming from right. So we have already pre-computed this 120. So for 1, what we'll do, the answer will be this suffix of this index is 0 0 plus 1, so it's suffix of 1. So for 0th index, the answer will be suffix of 1, because we already pre-computed the multiplication from the right. So answer will be suffix of 1. So for first index, what will be our answer? So let's see for 2. So for 2, it will be, we have to multiply these left elements and these right elements, so 3 4 5. So it will be suffix of this index, this index is 2, so suffix of 2 into, and what, and prefix, what we are storing the multiplication from the left, so it will be prefix of 0, 1 minus 1, which is 0. So prefix of 0, because till there the multiplication will be saved till 0. And for the second index, it will be similarly suffix of 3, 2 plus 1 into prefix of 2 minus 1, which is 1. For third, it will be suffix of 4 into prefix of 2. And fourth, it's a last index, so there is no suffix, so which is, it will be only prefix of 3. So this is the way we can solve this problem. We can store the left and right multiplication in the form of prefix and suffix arrays, and we can find these values in without using any loop in O of 1 time. So the time complexity will be O of n, and space also will be O of n plus n, which is n. So this is the approach. Let's code both the method solution out. So for first method, we will store the size nums in a variable n, and what we're going to do, we will create a vector, let's suppose answer, and first we will apply a loop, and we will take a variable, let's say value equals to 1. We'll again apply a loop, and if I equals to j, we will make it continue, because we don't have to multiply the same index value, else value is equals to value into nums of j, and we will push back this value in our array, in a vector, and we will return our vector answer. So let's run this solution. So it got accepted, but I don't think it will pass all the test case, because it will give us TLE. Yeah, it gave us TLE. So now let's code the solution of the optimized approach. This was just a brute force. So again, we have to store the, and we'll create answer vector, and we have to make two vectors of prefix and suffix. Yes, and we will make its length size n, and for prefix 0 we will store the first element, and for suffix of n minus 1 we will store it with the last. And for the prefix we'll start with I equals to 1, the first index. And what we do, the prefix of I will be nums of I into prefix of I minus 1, like the last index of prefix, its previous index of prefix into current element in nums of I. And for suffix, what we will do, we will start from the last second, and for suffix of I equals to nums of I into suffix of I plus 1. So it will be like we have multiplied till I plus 1, so it will be suffix of I will be nums of I into the multiplication of all the its rightmost elements. Okay, so now we will apply a loop, and if I equals to 0, then we will push back this value, which will be prefix of, no, sorry, it will be suffix of I plus 1. Else if I equals to, if I is n minus 1, that is last index, we will push back this value, prefix of I minus 1, because there will be no suffix. Else we will push answer dot push back prefix of I minus 1 into suffix of I plus 1. Okay, now let's return this answer. Let's submit. We got accepted. Great. Let's submit, and I most probably it will pass. Yeah, we got success. So this is the approach of this problem. We have to make two arrays, prefix and suffix. We have to first pre-compute the values, and at the end, without using any loop, we will just compute the obtain these values, and we will store it in our answer, and we will return it. So these were the approach. So thank you for watching, and I see you in the next video.